Okay, we're moving on to Chapter 5, Section 6, in which we're dealing with factoring special products. You recall in the earlier part we talked about multiplying a binomial squared, which was this here, and that produced a perfect square trinomial. And if we had conjugates, these were conjugates, they produced a perfect square, the difference of perfect squares. So what we try to do when we're factoring is to recognize if we have any of these special products, they tend to factor very easily. And there's some hints. As we look here, this is a perfect square, 100 is a perfect square, and the square root of 100 is 10, and if we double 10 we get 20. So this is a perfect square trinomial that will factor into x plus 10, the quantity squared. So if you square the first term, you get that. Multiply these two terms together, double it, you get that. Square the last term, you get that. Now, could you have done it the traditional way of two parentheses and all? Absolutely. But if you recognize this is a perfect square trinomial, saves you a little bit of time. And let's take a look at this one. Now, that's a perfect square. X squared is a perfect square. 144 is a perfect square. The square root of 144 is 12. If we double 12, we get 24. So this is a perfect square trinomial. And it will factor into x minus 12, the quantity squared. And if you check it, x square it, multiply these two together, double it, square this term, it checks out. And again, you can't always recognize them, but if you do, that's a good deal. Now our same rule applies. If it's in standard form, we want to factor out the greatest common factor. And let me put the right letter. So as we look at part 4, again, it's in standard form. And we take out, here we see a common factor of 3. So this becomes 25x squared minus 10xy plus y squared. And now this is a perfect square trinomial. Perfect square, square root of 5, 25 is 5, double it, 10. So this is going to be 5x minus 10, minus y. So if we square this first term, we get this. Multiply these two terms together, double it, we get that. Square the last term, we get this. And don't forget you need the 3 in front. Okay, again it's a special product. Perfect square trinomial after we factor out the 3. And it will factor into a binomial squared. So in these now, they're the difference of perfect squares in which we multiply conjugates to get the difference of perfect squares. So here we see in the first three the difference of perfect squares. X plus 8, x minus 8. Y plus 11, y minus 11. 5y plus 6, 5y minus 6. Again, if you recognize that they're the difference of perfect squares, now remember, you need to have that negative sign there. And you could put the positive, negative, or reverse them. That would be okay. Now so in number 9, what we need to do first is factor out the greatest common factor, which is a 3y. Then we're left with 4x squared minus 1. And there's our difference of perfect squares. So the 3y still stays. And we get 2x plus 1, 2x minus 1. And I'm going to be sure we get that in there. And it is in there. So all of these are conjugates. So if you remember, when you are foiling and you see conjugates as the binomial, they will result in that special product of the difference of perfect squares. All right, continuing on 5.6, some special products. So as we see something like this is a special product. And believe it or not, it's in the form of a squared minus b squared. So it will factor into its conjugates, which are 4x minus 1 minus 16. So we're taking this, put it there, and the minus 16. And 4x minus 1 plus, oh, not 16, it'll be a 4 there, excuse me. Okay, so once again, this goes there, this goes there, and you could have this as a positive or as a negative, or switch them around. That's fine. The answers come out the same. So this then becomes 4x minus 5, and this becomes 4x plus 3. So factoring this, noticing it's in this special form, this goes there, and then the conjugates, negative and plus of 4. And then you combine like terms. Now as you look at number 14, again you might say, oh, 4 terms. I'm going to factor by grouping. But no, that's not the way to do it. You have to think of it sort of like this. And you look at that and you say, oh, that's a perfect square trinomial that will factor into its binomial square. So once we change it from this form into this form, then we have the difference of perfect squares, and we do it like this. So one will be x minus 7 plus y, x minus 7 minus y. Again, this is a special product. Now, this next part of special products is something we treated as another video earlier, and it was called factoring the sum or differences of perfect cubes. And I'll review that recipe as we go on. So this is a perfect cube, this is a perfect cube. So it'd be the difference of perfect cubes. And we said the technique for factoring that was to make a parenthesis for 2 terms and a parenthesis for 3 terms. Then whatever sign we had there, we put there. And then the middle term of the 3-term parenthesis is the opposite sign. So setting up the signs is critical, and this is something you're going to have to memorize, or at least for part of the time you use your notes. So then you take the cube root of this, which is x, and the cube root of that, which is 10. Next stage was to square this first term, then multiply these terms together, disregarding that sign, because this sign takes precedent. This becomes 10x. And then you square that last term, that becomes 100. So again, a special product, the sum or differences of perfect cubes. This is the recipe. Square, parenthesis for 2, parenthesis for 3, whatever sign is there goes there, opposite sign there, cube root of this, cube root of that, square the first term, multiply these together, disregarding that sign, this sign takes precedent, and then squaring that last term. Now here we have a case where we have to factor something out first. We're going to take an a out of these. So a comes out, and now we have b cubed minus 27a cubed. So again, we have the difference of perfect cubes. So our a goes there, a parenthesis for 2, a parenthesis for 3 terms. This sign goes there, opposite sign goes there. Take the cube root of this, cube root of that. Now square this term, multiply these, disregard the sign, and that gives you 3ab. Square the last term, and there we have it. So again, you might look at the other video where I deal just with factoring the sum and differences of perfect cubes, but here's the recipe again and where you're going to need it. As you go into chapter 6, we're going to need these full time, but that's Math 109.